Hello, my name is Abigail, and today I will be presenting to you the design and implementation of the Arduino-based air quality meter using Blynk. The connections are displayed as we can see, but we will be seeing the hardware connections.
This is the hardware connections of our Arduino-based air quality using Blynk. So we will analyze the various components that constitute this project. So here we have the LCD screen. LCD also has an I2C adapter at the back, which connects the 4 pins into the Arduino. We'll analyze the various 4 pins connection. So for the ground of the LCD displayer, we have connected it also to the ground of the Arduino pin, which is over here. And then for the VCC, we have connected it, which is for the voltage Vin. We have connected it directly to the 5 volts of the Arduino. Then for the SDA and SCL, we have connected these pins into the A5 and A4. SDA is connected to the A4, and then SCL is connected to the A5 respectively. So these are the connections of the LCD display. Ground is connected to ground as mentioned previously, and then here we will be analyzing the gas sensors. So the gas sensor or the MQ2 sensor also connects to ground and connects to ground with this blue wire, and then it connects to the voltage, and the voltage is then from the breadboard connected to with the black wire to the 3.3 volts of the Arduino. So it's connected to the 3.3 volts, and then it feeds the MQ2 sensor. It feeds is into the AO pin. So its output, any data received from the MQ2 sensor, feeds into the AO analog input pin of the Arduino. So now we're gonna analyze the temperature sensor, also known as, which in this case is the DHT11 sensor, which is this blue sensor here. This is connected also to ground with this yellow wire, and then it's connected to, so its ground pin is connected to this ground of the breadboard, and then the black wire, which is its actual positive input, is connected to the 3.3 volts of the breadboard, which is also of the Arduino actually, and then the overall received data output is from this brown wire connected to the pin number 2, which is the digital pin, and we chose the pin 2 for preference reasons. So here is how everything is connected together. We use a USB cable to connect it to our Arduino IDE, and we will analyze the Arduino IDE code after this session. But this is how the connections are maintained. This is the reset button. Upon compilation of the code in Arduino IDE, you press this button to compile any new execution and view the output generated. The 3.3 voltage output from the Arduino is connected to the breadboard. The breadboard is quite small. As we can see, the LCD display is a 20 by 4 LCD. Why do we know that? Because we count the number of squares. The squares are 20 and then 20 by 4. If you want to display the letters in a much more smaller or bigger, you can just update it in the code. But this 20 by 4 will be useful in our code, especially over here where we determine the actual display size. This is it for the hardware connections. Hello, this is the software implementation of the Arduino IoT Blynk air quality sensor. We are using Blynk print 0 to print out any information that we are going to receive from the Blynk output. We're using the Blynk template ID, Blynk template name,
from the Blynk console, which we can see over here. Unfortunately, I have reached the limit, the free limit, so all my data has been wiped away from the erase data. Unfortunately, I clicked the erase data and I have deleted and erased all the previous data that I obtained, but I can show my findings from the snapshots that I took previously. Henceforth, I will be showing along the line the findings and the snapshots that I took. I would like to show you the output results obtained from the website. So from the website application, I obtained the following graph, which was giving the temperature 21, and then the humidity was 53%, and the gas level was 173. Right now, all the data has been wiped away, so I won't be able to present this at the moment. But this is for our own visualization. As we can see, the organization code matches, henceforth, it's proving that it was working beautifully before reaching the free limit. That being said, let's continue analyzing the code. These are credentials found in Blynk app, which can be obtained from going to the developer, which is our code. And then if I open up a little bit the web page, I can see this, which are the framework configuration. And you can just copy it by clicking click to copy code. So you can just copy, it says code copied clipboard, and you can just paste it here on your Arduino Uno IDE, on code. So after you've pasted, you can proceed. And this token was found, which is the authorization token, is found here on under devices authorization token. So this is the device that I created, and I linked it to my Arduino Uno Wi-Fi. So Arduino Uno R4 Wi-Fi. It presents the features and the data that has been sensed by the hardware configuration and hardware connection. So we have to include all these libraries, and then we include this data sensor. So this DHT sensor setup is the sensor for the temperature and the humidity. We are using DHT11. Henceforth, I put here DHT11 because this is the type of DHT that we are using in our code and in our implementation. The DHT pin is 2 because, as previously shown in the hardware connections, the DHT pin utilized was the digital pin number 2. So this is what we need to update in our code. And then continue, and we go and define the gas sensor, which is called MQ2 pin, and we establish that we're utilizing A0, which is the analog input 0 of the Arduino board, and we are just declaring it that we are utilizing that as the input value, input pin, sorry. The LCD setup, liquid crystal, we are setting up the LCD display 20 by 4, and then this is where the pin of the I2C address, it says the pin utilized. So we were able to obtain this value by debugging it and finding the value. So these are functions to literally connect the Arduino Uno R4 Wi-Fi to the internet, to the Wi-Fi. So we are using our credentials. So this is the Wi-Fi ID and the Wi-Fi password. So which is available on your router, and it's the same here. Wi-Fi credential from your router. So you use the ID, the username, and then the password. This means that this IoT system can work only with Wi-Fi or Ethernet or any internet connection. Without that, it won't work. So that's why we are using this as in Wi-Fi connection. And then we'll check that it's actually connected to the Wi-Fi. So once it's successful, it will say connected to Wi-Fi IP address, and it will state the IP address. We'll do an additional check because we are trying to connect it to the Blynk console, which is here, the Blynk app. So if successful, we will connect to Blynk, and then with Blynk.begin, we are authorizing, we are putting the authorization code, which is the authentication code, which offers security. We are offering security, so nobody that have the actual authentication can't access our device. Only those who have the authentication code, the authentication token, can access and edit our device, which is very important when building a device, especially an IoT system. This is our, again, Wi-Fi credentials. And then once successfully connected, we will print the Blynk connection started, which you can see here below in our serial monitor. Under here is the output of this serial monitoring. After that, we will continue and initialize the temperature humidity sensor. Then we will initialize the LCD sensor, the LCD, display, the LCD display, which is going to display the air quality and the temperature and the humidity. So we are going to have three values, three lines of displaying cursor. So we need one, position one, then the first position will be the air quality, and then the third position will be the humidity. So this is the initialization stage. The Blynk run code, which is actually part of the libraries in Blynk. So we are calling it and we are running it. This is found in Blynk Arduino client protocol. So all the library used are found here, installed, library manager installed, and we can see here that we did indeed download the Blynk by Volodymyr Shimansky. And then we have also downloaded other libraries just for commodity. We've downloaded the DHT11 and the DHT11, which is mentioned in the actual report. This is very important in order to have all the library interface, like for the temperature and the humidity. So it's very important. We also called and read the gas level for the MQT sensor. And then we send every data information in a virtual mode. So we are utilizing a virtual pin for each of the data received by the Arduino Uno. So for the temperature sensing, we are using the virtual pin V1. For the humidity, we are using the virtual pin V2. And then for the MQT value, which is the air quality value, we are using the virtual pin V3. Very, very important step, because this is what you use to perform the token, so perform the actual widget boxes. You will need to set up the pins. So into brackets, these are the pins that you're utilizing. And it's very important, because otherwise you will not be able to perform any operation, because you need those virtual pins. So you have to assign them on the code. It's very important. Once you've done that, you display the temperatures and humidity concentration on the LCD. There's a writing error. Correct that now. So this is when you have an LCD connected, as we do here. You will display the temperature and humidity concentration. So temperature measured in Celsius. This is the first data that we're analyzing. So first line of display, temperature, and then it will measure the value, and then so it's printing the value, and then we proceed with the actual unit, which is the Celsius. Then we go, this means the next line. So you indent or return, and you go to you write the humidity, sorry, which you can just abbreviate as hum, and then the value is printed, the value of the humidity present at that time, which is going to be alternating because we are measuring real-time quantities and values. So the humidity value, then we will also give it a percentage, because the humidity is going to have a range, is a gauge of the humidity present in the air. So a very high percentage of humidity means a non-breathable condition, suffocating a condition. And what is high? The high value is any value above 80 and above is considered high. Then we'll proceed, and then we will check the gas level. The gas level can range from any number from the lowest to the highest, being more than even 300 is possible, which is when it's really bad, there is a burning situation that can value. So we are putting it as the gas. It doesn't have any unit preceded, because it's just the value, a quantity, an integer that determines how polluted the air is. That being said, we propose this delay period, which is a delay period between each data received by Blynk. So we will compile and see what happens. So first we verify the code is working perfectly. Done compiling, compilation was successful. Then we upload into our Arduino. And it's done uploading as well. So I'm going to clear so that we can see the actual output. And then I'll click the reset function. And as we can see, Blynk connected, Blynk connection started, connecting to Wi-Fi, connected to Wi-Fi. And we can see that it has connected, and it says connecting to Blynk. Let's see again. Connecting to Blynk, Blynk connection started, ready. So we can see that our code is beautifully working and is also connected. which is what we want. So as it is connected, and if I could just use the free version, which I was using the free version, we could have seen these gauges changing inaccurately based on the current temperature. So we would see the values alternating. And if I proceed and literally use a lighter to burn or to burn a paper or to just infuse some form of heat and some form of gas, it will change the gas level, it will change the humidity, and definitely the temperature as well. The temperature will increase because of the heat dissipation, and that will be visible with these widget boxes. So I'm going to save here. Unfortunately, it's not very useful to display like this because of this limit, but what I can show is the fact that we were able to edit our data streams. So these are the pins B1, B2, B3, which were assigned in the code accordingly. So we can see that we have the units here perfectly displayed. We have the type, so integer or floating numbers, or double numbers or boolean. This will be possible to amend. If they were like a true or false, a switch function, you could change it not into a integer, but it could be a double. So web dashboard. As we can see, also another important thing is that this is showing how it is online. So we see when we set a Blynk connection started, it shows here as well that it is actually connected. Then this is the temperature. When we click edit, we could amend it. We can amend it. We can amend the threshold as well. We amend the threshold. We can change the color based on the value. You can save it. Beautiful. Same thing apply with the humidity. So we change the color based on the value. So in our app, phone app as well, all of this is displayed accordingly, and we can change the color setting to match or to differ based on how much we prefer. The gas level is 40, which suggests that it's very clear atmosphere, which is here. And then the higher the gas level, it becomes red. This is all possible to amend. So you can invert the gradient, you can edit the color scheme. I did change this to match it as my preference with the threshold that I have set. And you can also see that can change depending on the gauge that you try to use. You can use the different data stream as well. So supposing you want an LED or a label, so this label is the same as this temperature, gauge, humidity, radar, gas level. You want to incorporate charts, for example, you can do so. You can do so. You can incorporate, obviously there is no data at the moment, unfortunately, but you can do so by incorporating a data stream, which is the humidity gauge, for example. You want to measure the humidity. You can do that. You can do the average. You can do the charts like this. And you can even add more data streams if you wanted to. So let's say humidity data stream, or histogram, or humidity data. You can enable zoom, show legend, and then save. This will be visible. And then you save and apply. Beautiful. So this is our end result product. The same functions are visible also on the app. This is the website application. Obviously, we are just displaying how it looks like, but we can also determine everything on the actual app itself, which will be shown in the preceding screen grab. This is where I utilize this IP address to establish connection on the code, because when you go to your hub manager, you can see that this is the device that we are working on. If you click on it, it will say that it is connected. Indeed, it is online, it is connected. And it has the following IP address, and it is useful because when you are trying to establish connection of the Arduino Uno to the Wi-Fi, this IP address comes in very handy as it determines which IP address is your Arduino Uno using. This is a screen recording of my product, of my device. So here we can see the interface. Unfortunately, with the gas, the temperature and the humidity values at the moment in real time are not displaying any data because again we don't have the pro version of Blynk, but we can see that previously there were some form of data. So we can create widget boxes. We can choose a new one. If we select any, we can create like a simple chart and then create by choosing the temperature or the humidity. We can choose the type of data set to display, and we can also choose the time frequency that we want and the scaling and various functionalities. We can save it, and there you go, the app interface. This is a video that I posted on social media upon seeing that my app was successfully working, and in the excitement of it.
This is the demonstration of the final end product. We will see here that the device is offline, and we will now compile our code. So we will upload it. It's compiling and it's uploading. The device has now connected, as we can read below, connecting. So we will click the reset button to actually see the serial monitor connection. We have connected successfully to the Wi-Fi, and it's connecting to Blynk cloud, and we can see that the Blynk connection started. Now the device has come back online. We would have seen these values changing if we had the Pro version, but we can't see it will receive any data until the 30th of April. Now let's come here to our readings. So we can see the temperature is 21 degrees, the humidity is 52, and the gas level is alternating between 190 and 194. I will now induce some heat through a lighter. This will change the value of the gas level, and also the temperature will change. So I'm inducing this, and the gas level is arising. It's going. This is due to the heat dissipation, and also the air pollution be due to the flames. Thank you.